Here, it's 8:01. There, 2 o'clock. Good morning or afternoon, depending on where you are. I'd like to welcome you to a presentation on FHIR Shorthand. My name is Mark Kramer. My colleague, Chris Moselle, will be following up with a Let's Build session. So the two of us are responsible for FHIR Shorthand. I'd like to mention also that we're both from MITRE Corporation, which is a company in the US. It's a nonprofit, and we are largely funded by the US government. We've worked on a number of different FHIR projects over the years. You may have heard of some of them. Inferno, which is a testing suite or testing tool. M-Code, which is an implementation guide to do with oncology. Cynthia, which is a patient simulator. The CQL, which is a language to do logic across EHRs. And we've also been active in COVID, like many other companies. So welcome again to our presentation. This is a part of a sequence, which is the first for DevDays. We have a sequence of coordinated presentations talking about profiling and building implementation guides. And you may be interested in following up by listening to the other presentations, both Thursday and Friday, on how to build IG packages and using Simplifier to create those packages. The references are here in the slides, and of course you can download the slide deck to click on those links. So what we're going to do today is we're going to just have a quick overview of what FHIR Shorthand is, how it compares to other methods of creating implementation guides, and just demo a little bit of grammar of how shorthand works. And then in the Let's Build session, you will be able to build your first profiles in FHIR Shorthand and get some experience with Sushi, which is the FHIR Shorthand compiler. Chris Moselle will lead that. So what is FHIR Shorthand? If I refer to FISH, F-S-H, that's just an abbreviation for FHIR and the first two letters of shorthand. So I'll go back and forth between shorthand and FISH. It's a language. It's an invented language, a domain-specific language, as it's sometimes called, for profiling. And it's linked in with tools to create implementation guides. It is a standard of HL7. It's a standard for trial use, and one of the FHIR standards that I at the same level as FHIR mapping language, and some of those ancillary tools are also part of the FHIR family of standards. It's also integrated with the publication process. So if you publish your IG using the FHIR IG publisher from HL7, Sushi is, or FHIR Shorthand and its compiler, Sushi, is directly implemented, integrated with the FHIR IG publisher. It's completely open source and it's free to use. So you can do with it as you will. Just as an overview of different types of profiling approaches and why we think, how we think FHIR Shorthand fits in. We started off historically the first method was through spreadsheets, and you had to put together a number of different spreadsheets for each profile and manage those across multiple versions of that spreadsheet. And it's a little bit difficult to do that if you've ever tried to maintain a set of spreadsheets. And in fact, this methodology is phasing out. It'll no longer be supported in the future. At some time, it'll be phased out. I'm not sure when support will officially end, but that's the rumor at least. And then that evolved into more point and click graphical tools like Forge and Trifolia. And these are much nicer because there's some guidance in terms of where what you'd like to do and how to navigate around. And there's a little bit of hand holding involved, and it's a much nicer, more sensible interface than trying to edit spreadsheets. But still, there's a lot of point and clicking, a lot of navigation to get you from here to there and to accomplish things within these tools. And shorthand is declarative and command oriented. So I cut out a XKCD comic. You know, basically in shorthand, you have a command and our compiler will do that for you. So if you say, make me a sandwich, Sushi will do that. So it's a different style of interacting to create profiles and related tools. FHIR is actually a whole family of tools now. There's the basic language specification, which is the FHIR standard. That's, as I mentioned, an STU1. There's also a website, the School of FHIR, and I'm going to actually, part of being called FHIR is that people make up puns about FHIR Shorthand, and I ask you to bear with that. But FHIR School, FHIRschool.org is a website that contains a lot of useful tools, documentation of the Sushi compiler. It also has something called FHIR Online, which is an interactive version of FHIR Shorthand, where you can type shorthand in one box and see how that translates to FHIR. There is GoFish, which is a way to convert existing implementation guides into FHIR Shorthand. There's a tool for setting up a new project, which is part of Sushi. Once you've done that, you can download VS Code or similar editor. There's an extension that highlights code sensitive to the FHIR language as part of VS Code. And then the core Sushi tool, which compiles your FHIR Shorthand into FHIR artifacts, and Fish Finder, which is a crawler to find fish projects. And that's useful if you'd like to take a look at how other people have used FHIR Shorthand. And just to give you a sense of where we are in this project, we really just started this project a little over a year ago. And since then, we've had about 18,000 downloads of the Sushi package, which is the main tool that you use to execute FHIR. And that doesn't represent the number of users. It's each new version of Sushi requires a download, but it gives you a sense. The FHIR community is not that large. Maybe it's a few thousand people, but there's a great deal of penetration that we've gotten in users of FHIR Shorthand, and it's rising rapidly. The other thing to look at is this Fish Finder that I mentioned, which is a way to crawl the web and locate FHIR Shorthand-based IGs. And there are about 45 of them now that we've been able to locate. Excuse me, this crawler doesn't crawl the entire web, so we don't know exactly how many are out there, but it's a good number and it's growing. So you could take a look at that. That's also in FHIR School. So I've also added some quotes here, just a little bit of marketing, you'll have to excuse me, but people are pretty enthusiastic about using FHIR Shorthand. It gives you the ability to create IGs and a number of different FHIR artifacts like value sets, code systems. Examples are a big thing in creating an IG. So in addition to profiles, you can actually do quite a bit more with FHIR Shorthand. And people seem to like it. There's a very active community on chat.phir.org, the so-called Zulip chat. And if you'd like to see, get a sense of what's going on, please join the Shorthand channel on Zulip. So that's kind of the background, and now we're going to dive into a little bit of the FHIR grammar and show you how it's used. Now, I mentioned up front that this was part of a series of profiling tutorials and Let's Build sessions. That's all focused on COVID-19. And in the next session, we're going to talk about COVID-19 immunizations and in particular adverse events associated with those immunizations. But for this, I'm just going to use a different example. So we'll get back to the COVID. I've chosen to use an example that you can also reference just in the in other IGs. And this comes from the US Core IG, which is a fairly sophisticated IG, and this is their profile of medication request. And like many profiles, it has 4 or 5 different elements in the profile. It has a number of must supports, which you see as the red S's in the flags column. It has some special cardinalities, so it sets the repeatability and the requirement for certain elements. It has data type restrictions, and you see them in 2 places, one under the type, where it's restricting some of the references, it's restricting the types of elements, and you also see it over here in the restriction of these X variables, which are choices of types. So here, reported has been restricted to Boolean and reference. And finally, you see restrictions on value sets. So for example, the medication has to come from the US Core Medication Codes values set. And that's pretty typical, those kinds of constraints. So let's see how to create those constraints in FHIR Shorthand. Well, the first thing to know is that FHIR Shorthand is just text. You can use any text editor you'd like, whatever you're comfortable with, to create files that have the FSH or FISH extension. And those will be recognized as FISH files by the compiler. So although any text editor will do, we suggest Visual Studio Code because we've written an extension which allows you to, which will highlight the code for you. So to colorize the code to make the various pieces look different. And as we go along, I'll show code that has been highlighted using this extension in VS Code. But of course, you're free to use any editor you'd like, which is one of the nice things about writing FISH. So this is what a profile looks like, and this is the entire profile that you've seen 2 slides ago on medication request in US Core. And it probably looks like gibberish right now, so what I'm going to do is break this down so you can see the individual pieces. So first of all, at the very top, you see declarations and keywords. And the declaration is just the very first statement, and it says I want a profile, and I'll give it the name medication request FSH. So that's your declaration of what you really want to do. Then what follows are a set of keywords: parent, ID, title, and description. There's actually a few more keywords than that, and if you look at the documentation that's on FISH School and in the and on the FHIR IG website, then you'll see the full set of keywords. But right now, let's just focus on trying to understand what's here. Parent is the basis for the profile. Here we're profiling medication requests, so that's the parent of this profile. We give it an ID and a human readable title, and a short description of what that profile represents. So next there's a set of rules, and you'll notice that all the rules begin with an asterisk, and there's a half a dozen rules here, and this is really where the FISH grammar comes into play. There's different types of rules. Let's take them piece by piece. So this is these 3 rules are setting the must supports and also restricting cardinality. The first rule here says that the elements status, intent, reported, medication, and so on are must support. So you see this MS at the end. So that's going to set all the must support flags on this profile. The next two rules are going to set cardinality. So requester is going to be required. That means a minimum and maximum cardinality of 1. And the authored on similarly is going to be required and singular. And we use the same kind of expression of cardinality that you see in the FHIR documentation. So this could be upper bound of star would mean that it could repeat, a lower bound of 0, or any integer could be used in either of these places. Next, we have a set of 4 rules for setting the data type choices. And here the thing to notice is we're using only as a piece of the grammar. So all of these data type rules use the term only. So here reported, which is a X variable, so there are multiple choices. Reported is only a Boolean or a reference to US core patient, US core practitioner, or US core organization. And if we go back 2 slides, well, I have to undo the builds. You'll see that corresponds to this piece of the profile. It's a reported X is either a Boolean or a reference to these 3 other profiles. So that's what we're recreating here with the rules. So let me just go through the build to there. And it's very similar for the others. Subject is only a reference to US core patient, for example. So it's exactly the same syntax for those only rules. And finally, there's a value set binding. There's only one, where we're saying that the medication codable concept has to come from US core medication codes, which is the value set. And it's also an extensible binding. And as you may know, there's in FHIR, there's 4 strengths of binding: example, preferred, extensible, and required. And that's, we just denote that with parenthetical, that this is an extensible. So these lines of FHIR Shorthand captures that entire profile that we saw on the previous page. So that's pretty compact, which is really the purpose of shorthand. It's a short way to an efficient way to specify profiles. And just to kind of summarize what you've seen, each FHIR item, and profiles are not the only kind of items, consist of a declaration followed by keywords followed by a set of rules. And in addition to profiles, you can create code systems, extensions, instances, invariants, mappings, rule sets, and value sets. So all of these should be familiar to you, maybe with the exception of invariants and mappings, which are kind of a more obscure kind of feature of profiles. And rule sets, which are unique to FHIR Shorthand. And rule sets I won't go over, but it's a way to reuse a set of rules over and over again if you see them in the same place multiple times. The list of keywords listed here, this is a subset of the keywords, but these are the common ones. And then there's a set of about 10 different types of rules. And if you're interested in learning more about the whole thing, there's, of course, the official specification link was given earlier. So I would encourage you to go back to look at that. And I'm not going to cover the whole grammar in the 45 minutes that we've got. So another thing that you'd like to do with every implementation guide is to add examples. In fact, if you're going to do a HL7 specification, it's required that you have examples of each profile or extension. So let's go ahead and add an example of our medication request. So let's break this down. It probably looks like a bunch of gibberish right now, so let's break it down. So first of all, we see the declaration and keywords. So here the declaration is for an instance, and the name that we'll give it is medication request example 1. And instead of parent of or parent, we see instance of. So this is just saying that we're making an instance of our profile, medication request fish. And again, we have a title, a human readable type title, and a description. Here we're prescribing this particular medication. Then, of course, you see a set of rules. So the general structure here is the same. The rules, again, begin with an asterisk, so you can always see them. And in this case, notice that each one of these rules has an equal sign. And this is a type of rule we haven't seen yet. These are assignment rules. And what they do is they set a value in a fixed value in an instance. So an instance is a FHIR resource, and it's populated with values. So here all we're doing is populating it with a set of fixed values for the practitioner and the patient and so forth. The other thing which I've skipped over is this line at the very top, which is an alias. So FHIR Shorthand allows you to take long URLs like this and just assign a short alias. So here the code system for medications is RX norm. It's this long URL. We're just going to alias it to this string RX, or the symbol RX norm. And if you go further down, you'll notice that we're using this alias when we do an assignment. So we could just use this whole string down, this URL down here in the second green box, but it's just neater. And also, if you're referring to this string many times, it's preferable to use an alias just so that it's more readable. So all we're doing here is an optional readability kind of thing. There's a shorthand for setting codable concepts, which has a code system, then a hash sign or a pound sign, followed by a code. This is code 582620, and a string which sets the entire codable concept, which is this complex structure in FHIR, which you can do all in one go. So again, it's a code system, the pound sign, a code, and a string. And Sushi is smart enough to assign those to the right pieces of the codable concept complex data type. And a kind of reduced case of that is our codes. Here status is a code, and you'll always know a code or a codable concept by this hash sign. So we're setting status to active, and you'll see also we're setting the intent to the code order. So the hash sign indicates a code. A few other things to point out are setting references. So here we're setting the requester to a reference to another instance, practitioner 1, which is a practitioner resource. So here, this is just, we're not showing practitioner 1, but that's another instance example, which is in this, this IG. You'll also see things like dotted paths. So if you know the structure of medication request, it's got a dosage, and the dosage is a complex data structure that's kind of deep. So the dosage instruction has a timing, which has a repeat, which has a bounds, period bounds, and then a start time in there. So in order to get down that stairway of hierarchies, you just use dotted notation, and then you can just set it to a date time string. So I think that covers most of it. Strings are quoted. Oh, one more thing, quantities. So the way to express quantities in shorthand is to give a decimal or integer number followed by a single quotes with the units. These units are assumed to be from UCOM, the usual way that units, the usual code system or terminology for units, but there's also a way to set it to non-UCOM units if you'd like to do that. But this is the shorthand for the typical units bearing quantity. So now we've set up an example. Just for fun, let's set up an extension. This is where things usually get quite difficult in other approaches, but here we just have another declaration. The declaration is extension. We'll call this treatment intent. So we want to know what this drug is meant to do. That's the extension, which isn't built into medication request. And treatment intent has just 3 rules. And I'll introduce one new construct here. And this is the caret rule. A caret rule, you'll notice, has this little uptick arrow. And that's a way that you set metadata. In this case, the metadata appears in the structure definition for the extension. So it's not part of the treatment intent itself, but what these 2 lines are doing are saying that the context for this extension appears on an element, and that's a code, and it has a context of a medication request, which means this treatment intent extension is only allowed on medication requests. And then you have a more a binding rule, which you've seen before. This binding rule says that the value has to come from a value set. In this case, a treatment intent value set. Well, where does that value set come from? We'll do that momentarily, but once you've defined this extension, how do you insert it into our medication request? Well, that's with a different type of rule using the keyword contains. So back in the medication request FHIR profile, we'll add a rule, extension contains treatment intent, which is defined here. And then every extension has a local name named treatment intent. So we're just going to use the same name for its local name. And we have to give it a cardinality, and optionally you can give it a must support. So we've taken the extension, and in one line we've set it into, we've included it in the profile for treatment intent. We've given it a cardinality, and we've declared it a must support. So let's go back to this value set for a moment. So here is a definition of this value set also in FHIR Shorthand. And again, you have the declaration, which is value set, treatment intent VS for value set. It has an ID, a title, and description. Then we have a set of rules. Here's a piece of metadata. It's the copyright associated with that that value set. It's not part of the value set, it's part of the definition of that value set. So in order to get at the metadata, again, we use this up arrow, which is kind of going up into the metadata. You can think about it that way. And then here are the rules. There are 3 values in this value set. And the syntax goes like this: include SCT, and then the number sign, the hash sign with the code, and then a string. And what's SCT? Well, that's an alias that we set up here. Again, for brevity, it's optional, but SCT just refers to SNOMED. So now we've had a almost complete this exercise. I'll skip over this for now. Here's the entire set of examples that we've put together, or entire set of fish we put together. There are 48 lines in this file. It's a fish file. It's just text. And we've defined a profile, an instance, an extension, and a value set. So we can take this text file, which is remarkably small, actually. We can put it in GitHub or a similar source code control system, and we can manage it as as any other file of text. We can branch it, we can merge it, we can have multiple developers working on it at different times. They can fork it. So you can have a whole team working on your IG with different, fish files being active at the same time. And for larger projects, this is invaluable. The other thing that I should mention here, since it's just text, if you decide to rename something, you can just do a global replace. For example, if we don't want to call this medication request example 1 anymore, you just do a global replace on that name, and everything will change in consort with each other, and you'll maintain a coherent set of FHIR artifacts. And if you were clicking around to do this in a point and click tool, that would be much more difficult. Basically, cut, paste, and find and replace are my favorite parts of doing text. And they're used all the time. And they just make life so much easier. So I haven't gone through all of the syntax of FHIR Shorthand, but if you go to either Fish School or to the specification, here's the URL of the specification. You can download a cheat sheet which can help you learn the syntax and print this out and put it on your, put it beside your keyboard. One side has the syntax in an abstract way, the other side has examples. So this is very, very useful. Now, we haven't really done anything more than just define the things that we want in FHIR Shorthand. How do you actually turn that into some FHIR? So let's start with the way that a normal implementation guide project structure looks. It looks like this, and I won't go through it, but here's your root directory, and then there's a number of subdirectories. And what you have to do to add your FHIR Shorthand is just add a couple of things. Under input, you add an FSH, a fish subdirectory, and you put all your fish files here. And all your fish items are in fish files. It doesn't matter how you divide those up among the files, that's up to you. And then one more file, which is called Sushi config. It's a YAML file, if you know that syntax. So you just maintain exactly what you would do anyway and just add your fish files to that structure. And here's an example of the Sushi config. Again, you can read about this on Fish School. It has some metadata about how you're going to build your IG. What's the ID, what's the canonical, the name, the version, and other things like the license and the copyright, and dependencies are other external IGs that you'd like to pull in. So you can use any external IGs that exist. Here we're using US Core just to pull in some examples. So that's pretty simple. And now you run Sushi. You'll get an experience with this in the Let's Build shortly. Right after the break, we have the second session here, and we'll show you much more about how to use Sushi. But it's once you install it, which is a one-liner, just npm install -g fish sushi. Once you install it, it'll download and install that package. You open a command window, you navigate to your root directory, which is your IG root, whatever you call it. You don't have to call it that. And you type the magic word sushi. And that's it. So what happens next is that Sushi runs and it creates another directory, fish generated, which has all the compiled resources. We use JSON, we do not use XML. If you'd like XML, there's translators that you can use from JSON to XML. But these are all your resources. You see the code systems, you see examples, you see structure definitions, value sets, and one key is an implementation guide resource, which is quite complicated. We put it together for you. And there's an override, in fact, if you want to bring your own, you may do that. The other thing is you can bring your own resources that are not fish resources if you'd like. And the the Sushi knows what to do with them. The publisher knows what to do with them. So you can mix and match some fish and some other, maybe you did it with Spreadsheets, maybe you did it with Forge. That's perfectly okay. When you run Sushi, you may get errors. Just like any compiled language, the compiler can spit out errors. Here is an example of Sushi running, and it points out the error very nicely. It says there's no definition for US core organization. Well, that's just a typo. You can see it there. And where is it? Well, it's in this file on this particular line. So it tells you exactly where to look for your error and makes it as simple as possible to find, identify, and fix those errors. And it gives you this nice scorecard down here, how many profiles, how many extensions, value sets, code systems, and instances it created. And then it gives you a smart aleck remark like, this was a turtle disaster, one error. So that's pretty nice. And then to run, so that only gives you the FHIR artifacts, right? It just builds these FHIR artifacts. If you'd like to run the igProfiler, then there's a different script to run. You open your command window, you run update publisher, and you run gen once, a script that is provided in the sample IG. And then Sushi automatically runs when you do that. The IG publisher knows that you've got some Sushi there. It'll find it and it'll run run Sushi for you and produce your IG. And it will, like we've done before, it'll produce the fish generated folder, and it will also produce an output folder. And inside the output, you'll find index.html, which is your IG home page. So it's pretty simple and transparent. And when you open index, it'll show you the pages that it's built. And again, it's pretty amazing that only 48 lines of fish in this case give us a profile, an instance, an extension, and a value set, a completely valid IG, a complete but small but complete IG. And I won't do this now, but if you look at this medication request profile, it is exactly the same as the one that's in US core. It also has the value set with the values. It completely built out the page. So this is really nice. And I'm sure you're saying to yourself, that's nice, but I already have an IG. So if you have an IG and you're interested in using fish, you can use GoFish. And GoFish is a beta. Here's your beta fish. At least that's what we call them in the US, beta fishes. So it's a beta fish. It's very simple to install. npm install -g GoFish. It'll install that package. You navigate to the directory that has your existing structure definitions, and you type GoFish. And the results will appear in the GoFish subdirectory. So it'll convert right now all the structure definitions that you have. Limitation is that we won't yet, but very soon we'll translate all of your value sets and instances to GoFish as well. Excuse me, to fish as well. Here's an example of GoFish Output where I took the US core profile for medication. Actually, I just reversed engineered the medication request fish.json file and reversed engineered it through GoFish. So it takes that structure definition, which is, by the way, 1,000 lines long of structure definition of JSON, and reverse engineers it back to fish. And it looks a little bit different because you notice that the must supports are on different lines. But in every way, this is fully valid fish, and it gives you a starting place to create your project using FHIR Shorthand. So that's the end of this tutorial. I hope that you have learned what FHIR Shorthand is all about, how it compares to other methods of creating implementation guides that you can also learn about during DevDays. I've introduced some fish grammar, basically intuitively. There's lots of reference If you just Google, FHIR Shorthand build session, where you can create your first FHIR Shorthand project using our COVID example, and you can get some hands-on experience with Sushi and build yourself your IG. So at that point, I'll open it up for questions. I think we have about 3 or 4 minutes left. Michael, do we have any questions out there?
Yeah, there are about 4 questions, and I'll go ahead and read them off. So does FHIR come in Java and integrated in IDE such as Eclipse or Intel IJ, or only is it VSC, Visual Studios? What is the difference between Forge profile and creation and FHIR?
Okay, so one at a time. So FHIR Shorthand is a specification. It's not in any language. Let's just make that clear. And that specification is an open specification, and it can be implemented. You can implement a compiler in any language you'd like. Now, it turns out Sushi, which our team has written, is written in TypeScript. TypeScript is a kind of JavaScript. So no, we haven't implemented it in Java. And we do not have a IDE such as Eclipse or IntelliJ. So that doesn't exist, but you are, if you're interested in doing that, you could do that maybe even by translating, starting by translating the JavaScript somehow to Java. So no, we don't have that. And what was the second question, Michael?
Yeah, second part of that question was, what is the difference between Forge profile creation and FHIR?
So the end product is the same. You get a valid FHIR profile, but the process is different. I mean, with Forge, you're navigating through a set of screens to create your sets of profiles, and it's point and click as you fill in the various parts of your structure definition. In FHIR Shorthand, the front end is a language. It's a declarative language. You express what you want rather than saying how to do it. And so the front end is completely different, but the result should be the same. And you can mix and match these techniques to your heart's content, where, some of your profiles or some things might be managed in Forge and other things managed in Shorthand. I hope that answers your question.
Yeah, very good job. Can we create multiple instances from reading predefined data?
So I'm not sure I completely understand that question, but when you say reading predefined data, so if you want to create a translator that goes from, I don't know, some other format for your, goes from a database and exports to fish, and then you run Sushi, there's an embedded way to run Sushi, a command, an API, which then produces FHIR instances. Yes, you can do that. If you have a database and you want to export resources, then it's entirely reasonable to write a translator that first creates FHIR Shorthand and then in the same stroke or subsequent, immediately thereafter runs Sushi to create the resources. And you might find that an easier path. In fact, I know of one organization that is doing that. They've got internal representation. They do a translation of FHIR Shorthand and then to FHIR resources.
Okay, thank you very much. And Mark, there are a couple other questions, but we're out of time. So maybe you could go in and look at those. A couple of the questions have also responses from others. So for those on the call, you could look at if you have the question, go ahead and look at the question and answers section.
Well, I can hang on during the break for a few minutes. And if there are more questions, let's see if I can even stop sharing. And anyway, thank you very much for your attention. Come back in 15 minutes and we'll have the Let's Build session. look forward to that. All right, so I'm still on. I have to go to Hoover. Right. Hold on just a second.
Yeah, in Hoover, they can raise their hand. If they open the participants panel, you'll see those that are left, and then we can unmute them. Actually, I'll unmute all, but I may have to mute it back. Oh.
All right, I'm still navigating to FHIR Shorthand here. Oh, this is not working well. Wow, that's weird. That is really weird. I think I'm in the wrong conference. Why is Hoover doing this to me? So I'm having some trouble accessing. If anyone wants to ask a question verbally, please do that and forget about the chat.
Well, Mark, I did put in the chat the Hoover
Oh,
instance,
okay.
so go ahead and click on that.
Thank you. That helps a lot. I just couldn't find my session in Hoover. Is it possible to validate with Sushi the canonical URL reference within? Yes. If there's an invalid URL reference, then Sushi is pretty good in tracing down URL references that do not exist. They have to be in either the one of the dependent IGs or in the fish file or in your project itself. Thank you, Dylan, for that question. And then I see one, I don't see the full one. Instance example, is it supposed to be used in place of a JSON instance? Well, that instance example actually is turned into JSON. So the, you write it in Fish and then Sushi turns it into a JSON instance that's valid and that you can send using the using a regular FHIR API. So the idea is that shorthand is only a temporary format which you can use to create your IG and maintain it that way. It's a very convenient way to maintain a project. And then actually when you're creating the IG or you're exchanging FHIR, it all becomes JSON and the validator is in Java. So it's just a language to get you to the point of having a validated IG and instances if that's what you'd like. So I don't see any more questions, so thanks. I'm going to drop off and rejoin into the following session, and thank you again.
Thank you.